Hello, in this video we're going to talk about inequalities with one variable. We're going to start off with some stuff that you'll probably remember because it's pretty simple and we use it pretty often. Imagine you have this equation here, x plus 5 equals 3, and you need to solve it. To isolate that x variable, you're going to subtract 5 from both sides, and you'll get x equals -2. And if you wanted to graph that, let me move these up. If you wanted to graph that, you would make a number line. Slide that down a little bit. And you could say if this is 0 and this is -2, and you would make a dot here to make it green. So there you go. Graphing an equation. Just making a dot on a number line. Pretty simple. So let's say you were doing the problem on the right. Again, you probably remember this. You have to divide both sides by 2, and then you end up with x equals 4. And if you wanted to graph that, you would draw a number line, label a point or two, make it 2 points, and we can put a dot at 4. So now, if we look down here, I have a new problem, except instead of an equation, it's an inequality. It's essentially the same thing. We have x plus y, we have a 3, except instead of equals, it says less than. Well, we actually solve that the same way. I'm going to subtract 5 from both sides, and I'm going to get x is less than -2. So it's almost the same, except instead of equals, it's less than, and it's solved, like I said, the same way. And the difference is in the graphing part. So if I have the 0 and the -2 here, instead of putting a dot on -2, I'm going to put an open circle to show that -2 is not part of the answer. But everything less than -2 is, like -3 and -5 and -10 and -1,000,000. So I'm going to shade that arrow too, showing that forever and ever and ever to the left on the number line, anything there is a solution. So everything in the shaded region is true, makes this statement true. The -2 itself is not true, but it is the boundary, so I have to make some sort of mark there to show that -2 is the highest point that would work, or in this case would not work, but everything below that does work. Alright, so let's move on to the 2x is greater than or equal to 8. So here I'm going to divide both sides by 2, similar to the one I did above, and I get x is greater than or equal to 4. Now this is slightly different from the previous example in that because of this equal sign here, this statement means, well, x is greater than 4, like 5, 6, 10, 1,000,000, but it could also be equal to 4. So 4 does work, and so to show that, we make a solid dot, kind of like above. So anytime there's an equal sign, or half an equal sign in this case, we use a solid circle, a solid dot. But I also have to show that greater than 4 works too, so I need to shade up here to the right, greater than 4, like 5 and 10 and 1,000,000. Alright, so let's try another example here. Here we have y minus 7 is greater than -5. I'm going to add 7 to both sides. And my answer is y is greater than 2. So if I want to graph that, I'll show 0, I'll show 2, so I need greater than 2, that means open circle, and shading to the right. Now the blue part, the blue equation or inequality, I need to multiply both sides by 4. Okay, that crosses out that, leaving me with what I want, which is that isolated variable, and I get 12 on the right side. Again, graphing that. I'm going to label 12 here, put a 0 somewhere. And I have a solid circle because there's a part of an equal sign there, and everything less is correct. So I shade everything to the left, including that arrow. Alright, let's move on here. So now there's a special case. So let me put a little shade up here for a minute. So imagine we have 2 equals 2. We all know this is a true statement. And we also know that if I multiply both sides by a negative number, that I continue to have a true statement, because -2 is in fact equal to -2 as well. So I'm allowed to multiply both sides by a negative number. Same thing is true in this case here. I can multiply both sides by -1. Except, let's see what happens. I get -2, and I get -4. Is this a true statement? 2 is less than 4, so we can all agree that the top red statement is true. But -2 is actually greater than -4. So the special case is when you multiply or divide an inequality using a negative number, you have to switch the direction of the inequality. So we have to switch that to this direction. This is true for division as well. If you were to divide both sides by -1 or -2 or whatever, as long as it's negative, you have to change the direction of the sign. Okay, so keep that in mind. That never came up in the equations because it's true no matter what you multiply by. But in inequalities, if you multiply or divide by a negative, you must switch the direction of the sign. So let's do a couple examples. In this one, I'm going to divide both sides by a negative number. Therefore, when I get my answer, I need to switch the direction of the sign. And then I can graph it as normal. So here's -4. It's open circle and everything less. Okay. Again, on the right equation here, I'm going to multiply both sides by -5. Since I'm multiplying by a negative number, I'm going to have to switch the direction of that sign to greater than or equal to. Okay. To graph that, make my number line, show -10. Again, you don't have to show too much on the number line. Just show me that you know that a negative is to the left of 0. And we need a full filled in closed circle on -10 and shading everything to the right. Okay. Quick example here. This is not a special case, and let me show you why. I'm going to multiply both sides by 5. I'm going to multiply both sides by 5. Now, the number I'm multiplying by is a positive 5. So although there is a negative number over here that is involved in the multiplication, it was already there to begin with. So do not switch the sign in this case, okay, because I was multiplying by a positive number. Okay, so even if a negative number is involved, the question you have to ask yourself is, did I multiply or divide both sides using a negative number? Okay, and you know how to graph that at this point. Thanks for watching.